Hello friends, this video Limits and Derivatives Part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 3. Let's take one more example. Here we have this function x square plus x. We have to find this limit at x almost equal to 3, x tending to 3. So this case, let's again plot the graph. Let's suppose this is 0, this is 1, this is 2, this is 3, this is 4. So x is equal to 0, you get 0. X is equal to 1, you get 1 plus 1, 2. X is equal to 2, you get, this is f of 1 is equal to 1 plus 1 is equal to 2. F of 2 is equal to 2 square plus 2, that is 4 plus 2, 6. F of 3 is equal to 3 square plus 3, that is 9 plus 3, 12. And f of 4 is equal to 4 square plus 4, that is 20. You see these values are increasing exponentially. So we can say that this is 0 and we'll assume that this is 20, 5, 10, 15, 20. We'll assume that this is 5, this is 10, this is 15, this is 20. So we see f of 4 is 20, so this point is 20. F of 3 is 12, almost near this point. This is 15 here, sorry. And f of 2 is 6, almost this point. F of 1 is 1, almost this point. And f of minus 1 will also, f of minus 1 will be, f of 0 is 0 and f of minus 1, if you put f of minus 1, that will become 1 square plus 1, that is 1 square minus 1, that is 0. So f of minus 1 is also 0. So this is minus 1, this value is also 0. F of minus 2 is equal to minus 2 square, that is 4 minus 2, that is 2. So this is equal to 2. We'll find one more value. F of minus 3 is equal to minus 3 square is equal to 9 minus 3, that is 6. So this guy is 6. So we have graph something like this. I'll draw the graph. The graph will be something like this. Something like this. Something like this. This is the graph we get. Correct? Now we have to find at x is equal to 3. So x is equal to 3 are this point, that is nothing but 12. So this is our point now. This is the point in. Approach this point from the left hand side. So when I say limit of x is equal to 3 minus of fx, that is nothing but f of, let's suppose, 2.999. Correct? Because I'm taking a value that is near to 3 but less than 3. This point, somewhere here, very near to 3, that is 2.999. So that is nothing but 2.9999 square plus 2.9999. And this value, if you calculate, you'll get something like 11.999, something of this sort, and that is almost equal to 12. Similarly, when you talk about limit of x of 3 plus, that is any number that is near to 3 and greater than 3 but not 3, so that is something of this sort, 3.0001. correct? So this number, if you say, this value is nothing but 3.001 square plus 3.0001, and this value is of this form, 12.007, something of this form. If you calculate, you will get the actual value, but this will be of this form, and this value is almost equal to 12. So what we have until now, we have first plotted the graph based on various values of x, we got y's, and then we have found that limit of fx where x limits 3 minus is almost 12 and limits of fx x 3 plus is almost 12. So now we observe that here also left is equal to right limit. that is left limit is equal to right limit. So we can say that limit x is or tending to 3 of fx, here also it exists, and that's value is nothing but 2, and that is our answer. Correct. What we have done, we have first plotted the graph and we have found limit of x3 minus and we have found limit of x3 plus, and we observed that both the values are almost equal to 12. Thus we concluded that since left limit and right limit are equal, so the limit at x is equal to 3 for this function fx exists, and that value is 12. We'll take one more example. We have to find the left limit, right limit, and the limit at x is equal to 0 for this function. For any number that is less than 0, the function value is 1, and for any number greater than or equal to 0, the function value is 2. So this 0 is included here. So the function value is any number less than equal to 1 is 1. So this is for any number less than equal to 1. Please note 0 is included here. And any number greater than 0, that is this part here is not, this 0 is not including. Any number greater than 0, that is 0.11 to any number, this value is 2. This is 1, this is 2, this is 3. Correct? So if you see at x is equal to 0, the value is 1. At x is equal to 0.001, the value is 2. Now let's find the left limit. So limit at x tends to 0 minus, we are approaching this function from the negative direction, this direction, left direction. So we see that this is nothing but anything less than 0 is 1, right? That is nothing but anything less than 0 we can say is minus 0.9999. Correct? This is value less than 0, and this value is nothing but 1. Similarly, if you want to find the value of this limit for x 0 plus, that is the right limit, that is nothing but f of 1.0001, correct? And f of 1.001, any number that is greater than 0 is 2. This value is, let me repeat what I have done. Limit 0 minus is any number less than 0, that is 0.99999 minus, and that value is 1 because f of any number that is less than 0 is 1. So f of minus 0.9999 will also be 1. Similarly, limit of x 0 plus, we can take this value 1.0001 or 0.001, sorry, because any number that is greater than 0 and almost equal to 0 is 0.0001. So f of 0.001 will use equation because this number is greater than 0 and that value is 2. So here we have seen that in first case we got 1 and second case we got 2. So here we will say that left limit is not equal to right limit. Since left limit is not equal to right limit, in this case we say that limit x tends to 0 for fx does not exist. Please note here the limit at x is equal to 0 for fx doesn't exist because the left limit is not equal to right limit. The left limit is equal to 1 and the right limit is equal to 2. This is the one example where x tends to 0 is not defined. Here we have to find left limit, right limit, and limit at x is equal to 0 for this function. And this function, the value of fx is equal to 1 for any number that is less than 0 and fx is equal to 2 for any number that is greater than 0. So let's suppose this is 0. This is 1, this is 2, this is 0. So for x is equal to 0 and less than 0, y is equal to 1 always. So this is the from here to here. And for any number that is greater than 0, 0 is not included, the value of y is 2. This is the typical graphical representation of this equation. Fx is equal to 1 for any number equal to 0 or less than 0. So this at 0 point, this value is 1. And fx is equal to 2 for any number greater than 0. Now let's find the limit. So in case of limit x is 0 minus left limit of fx, that will be any number that is less than 0 and almost near to 0. That will be f of minus 0.00001. Let's suppose you take this value. And f of minus 0.001, if you see, will be somewhere this point. So for this point, the y is 1. So this value is nothing but 1. The value of this function at x is equal to minus 0.0001 is equal to 1. Similarly, let's find the right hand limit. X is 0 plus of fx is any value that is near to 0 and greater than 0. Let's suppose 0.0001 I'll take. So f of any number that is greater than 0, this point is 2. We can see for this point, if you see, the value is 1, and for any number which is greater than 0 at this point, the value is 2. This is equal to 2. So here you see the left limit is not equal to right limit. Why? Because the left limit came out to be 1 and the right limit came out to be 2. So 1 is not equal to 2. So left limit is not equal to right limit. So we can say that limit of this number at x is equal to 0 of this function is not defined. This function is the limit at x is equal to 0 for fx is not defined in this case. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.